Uy, nariyan ka na pala. Kumusta? Maligayang pagbabalik sa iMath UPD channel. I am Sir Prince and I will be your discussion teacher for this video. In this video, we will answer more exercises on double integrals in polar coordinates. And this is part 1 out of 3. But before we start, here are some study tips that you can remember. First, you can pause the video if you want to try answering a problem on your own. You can rewind the video to listen once more to certain portions of this discussion. You can inquire or consult your discussion teacher during discussion classes. And then you can note down important tips and strategies. And comment if you have something to say. And then finally, syempre, enjoy lang natin yung pag-aaral ng mathematics. Okay ba yun? Let's go to the first set of our exercises. Here, we want to evaluate the following integrals using polar coordinates. So, given tayo ng region of integration natin. Anong gagawin natin dito? We implement a three-step approach for a more organized solution. Ano yung tatlong steps na yun? Una, we sketch the region of integration, and then we convert to polar form, and then finally, we do the integration. Okay? So again, sketch, convert, and integrate. Sketch, convert, integrate. One more time. Sketch, convert, integrate. Yay! So let's go to the first item. We want to find the double integral of sine of x squared plus y squared dA over the region enclosed by the circle x squared plus y squared equals 9. Pause to try answering the problem, then continue after. Ang solution at answer ay paparating na in 5, 4, 3, 2, 1. Ayan, so tignan natin kung tama ba ang iyong mga sagot kung ikaw man ay nag-pause kani-kanina. Let's go. So dito, sketch muna natin yung region of integration. We have the circle x squared plus y squared equals 9. So centered at the origin with radius square root of 9. So radius 3. So we have the following. The region we want is enclosed by this curve. So we have this purple region. Now, we proceed to converting our Cartesian equation to polar equation. So yung x squared plus y squared equals 9 natin, dahil centered at the origin naman yung circle natin, ang polar form niyan ay r equals the radius. So we have r equals 3. Take note na ang ating region of integration ay nagsisimula dun sa origin, dun sa center ng circle. So dito r equals 0. And then i-increase natin si r hanggang makarating tayo dun sa bounding circle. Dito sa bounding circle, we have r equals 3. Kaya naman ang r interval natin ay from 0 to 3. On the other hand, for the theta interval, kailangan nating tanungin ang ating mga sarili. Ano-ano bang values ng theta yung enough na para matrace natin yung buong circle? Kasi ang ating region enclosed by the entire circle. So kailangan natin yung pang-trace dun sa buong circle. So kapag centered ka sa origin, ang pang-trace sa iyo ay tama mula theta equals 0 to theta equals 2 pi. Okay? So for our r interval, we have 0 to 3. And for the theta interval, we have 0 to 2 pi. Okay na tayo sa limits of integration in polar form. Next, hanapin natin yung ipapalit natin sa integrand. So meron tayong tatlong equation na makakatulong doon. We have x equals r cosine theta, y equals r sine theta, and x squared plus y squared equals r squared. Pero specifically to this problem, may x squared plus y squared lang naman dun sa ating integrand. So ang gagamitin na lang natin ay yung equation na x squared plus y squared equals r squared. Okay? And then si dA, recall na ang pamalit dyan ay r dr d theta. Huwag kalilimutan si r ha, kailangan kasama si r sa dr d theta kapag ang pinapalitan natin ay si dA. Okay? Hence, now, the integral becomes the double integral of sine. Ito ay magiging r squared. And then, yung dA ay r dr d theta. Okay? And then, inner integral is with respect to r. So, we put here the limits of integration na galing sa r interval. So, 0 to 3. And then, dito naman ay yung galing sa theta interval. Kasi ang outer integral ay with respect to theta. So we have 0 to 2 pi. Okay? We will not detail here the solution for the integration. Sasabihin ko na lang kung anong gagamiting technique. Kasi nagtitiwala ako sa inyong kakayahan na mag-integrate. Okay? So we can skip that part. But just in case nakaligtaan ninyo yung mga techniques natin, pwede kayong dumalaw sa Math 21 playlist at Math 22 playlist dito sa iMath UPD channel. Balikan nyo yung Unit 4 at Unit 1 ng Math 21 and Math 22 respectively. Nandun yung mga integration techniques. Okay ba yun? Alright. So dito, ang pwedeng technique ay, sa inner integral ay u substitution where u is r squared. Okay? If you do that, you can verify that the antiderivative with respect to r is negative cosine of r squared over 2. So evaluate lang natin from 0 to 3. Kapag 3, we have negative cosine 9 over 2. Kapag 0, we have negative cosine 0 over 2. So ito ay negative cosine 9 over 2. Ito naman ay magsisimplify pa as minus minus, so plus na lang. Ang cosine 0 ay 1. So we have plus 1 half. Okay? And then this is a constant. Kaya kapag nag-integrate tayo with respect to theta, i-attach lang natin si theta dito. So we have 1 minus cosine 9 over 2. Ito lang yun. Multiplied by theta, evaluated from theta equals 0 to theta equals 2 pi. Okay? And evaluating, we get the following. So pi minus pi cosine 9 for theta equals 2 pi and 0 for theta equals 0. And so our final answer is pi minus pi cosine 9. Okay. Nice, nice. So proceed tayo sa second example. We want to get the double integral of 1 over the quantity of the square root of the sum of x squared and y squared over the region inside x squared plus y squared equals 2y and outside x squared plus y squared equals 2. Okay, gamitin ang kapangyarihan ng pause upang subukan munang sagutan ang problem. Paparating na po ang solution at answer in 5, 4, 3, 2, and 1. Let's go. So again, sketch muna tayo. So maganda na alamin natin kung ano bang mga curve yung dinedefine ng mga equations na ito. Itong pangalawa, this is clearly a circle centered at the origin with radius square root of 2. Ito kaya, sa mga sumubok magsagot, at nakuha kung anong curve ito, probably nag-complete the squares kayo. Kapag nag-complete the square tayo, ang mangyayari dun sa y squared minus 2y, add lang tayo ng 1. And then, express natin ito in terms of this form. Okay? So dito, kita na natin na ang ating curve talaga ay isang circle din, this time centered at 0, 1, and with radius 1. Okay? So sige, sketch na natin ang ating region of integration by first sketching our curves. So the red circle has center 0, 1 with radius 1. So ito yun. The blue circle has center 0, 0 and radius square root of 2. So ito yun. Now, saan dyan yung region of integration natin? It is inside the red circle. So inside this one. But outside the blue circle. So ito yun. Itong portion na ito. Kulayan natin. We have this. Okay na tayo sa sketch. Meron na tayong region of integration. Na-visualize na natin siya. Proceed tayo sa conversion. So convert natin si blue circle. Siya ay centered at the origin. Kaya naman yan ay may polar equation lang na r equals the radius. So we have r equals square root of 2. Ngayon, si red circle naman, iba na yung center niya. Wala na sa origin. Rather, it is on a point along the y-axis except dun sa origin. So paano nga ba yung polar equation yan? Recall natin from polar curves. Kapag ang center mo ay 0a, where a is non-zero, ang equation mo ay r equals 2 times a sine theta. So sine theta kasi yung mas related sa ating y-axis. Or in polar plane siya kasi yung lumalabas na pi over 2 axis natin, di ba? Okay? So we get r equals 2 times 1 sine theta. And then if we simplify that, we just get r equals 2 sine theta. Okay? Hence, for the r interval, our bounds is square root of 2 and 2 sine theta. Kasi nga naman, itong galing sa blue circle, yung mas malapit sa pole or sa origin. And then ito namang nasa red, yung mas malayo. So ang upper bound natin ay yung mas malayo. So 2 sine theta. And ang lower bound ay yung sa mas malapit. Yun yung square root of 2. Okay? Now for the theta interval, kailangan lang natin kasing matrace itong portion na ito ng red circle at itong portion na ito ng ating blue circle para ito lang yung region of integration natin. So kailangan natin makuha yung theta dito at saka yung theta dito. Okay? So we solve for the intersection of the red and the blue circles in quadrant 1 and the intersection then in quadrant 2. So we equate square root of 2 and 2 sine theta. Yun yung values kasi ng R for the circles. So 2 sine theta equals square root of 2 and then divide both sides by 2. And then finally, we want a theta in quadrant 1 and quadrant 2. Tapos yung nasa 0 to 2 pi na lang. So we get theta equals pi over 4 to 3 pi over 4. Ito actually yung sa pi over 4 and ito naman yung sa 3 pi over 4. Hence our theta interval is pi over 4 to 3 pi over 4. Okay? And now for the integrand, ang kapansin-pansin lang dito ay si x squared plus y squared. Palitan na yan ng r squared. Si dA naman, again, r dr d theta lamang. Okay? Hence the integral will become the double integral from pi over 4 to 3 pi over 4, then square root of 2 to 2 sine theta ng 1 over square root of r squared. Yung pumalit sa x squared plus y squared, and then r dr d theta. Yun ang pumalit sa dA. Okay? So take note na si square root of r squared r lang naman kasi non-negative naman si r natin dito. And then magka-cancel na dito sa r. So dito we just have 1 dr. Kapag ganun, di ba ang gagawin lang doon? Pag-minusin lang natin yung limits of integration. So the inner integral will simplify to 2 sine theta minus square root of 2. And then we will integrate with respect to theta. So si 2 sine theta, ang antiderivative niyan ay negative 2 cosine theta plus c. Si negative square root of 2 naman, ang antiderivative niyan ay negative square root of 2 theta plus c. So we have the following. Evaluated from pi over 4 to 3 pi over 4. Take note na sa 3 pi over 4, ang cosine ay negative square root of 2 over 2. Kapag naman pi over 4, ang cosine ay square root of 2 over 2. Okay? So evaluating lang dito sa mga bounds natin, we get the following, and then if we simplify this, combine natin yung mga may kasamang pi at yung mga walang kasamang pi. This is equal to 2 square root of 2 minus pi square root of 2 over 2. This is now our final answer. Okay? Now for the third example, we have to calculate the double integral of 1 over the quantity 1 plus x squared plus y squared over the region in the first quadrant bounded by y equals 0, y equals x, and x squared plus y squared equals 4. So, subukan nyo muna. Pause muna ito para inyong masubukan naman magsagot. Solution and answer arriving in 5, 4, 3, 2, and 1. At ito na nga. So again, sketch muna tayo ng region natin. It is bounded by y equals 0, so yun yung x-axis, by the line y equals x, and itong pangatlo ay isang circle lang din centered at the origin. So we have the x-axis, the line y equals x, and the circle x squared plus y squared equals 4. So yung bounded ng mga yan sa first quadrant ay itong portion na ito. Okay? So we have the following. Itong violet na ito. But just a note, itong intersection dito, paano nakuha yun, gawin nyo lang to. Okay, so equate natin. Gamitin natin yung equation na y equals x at yung equation x squared plus y squared equals 4. So yung y dito, palitan mo lang ng x to get x squared plus x squared equals 4. So that simplifies to 2x squared equals 4. And then finally, we have x squared equals 2. So x is plus minus square root of 2. But kailangan natin yung nasa first quadrant lang. So positive dapat ang x doon. Kaya we just took square root of 2. Okay? Now, hanapin na natin ng ating r interval and theta interval. Yung x squared plus y squared equals 4 ay r equals 2 lang kasi centered naman siya sa origin. So r equals the radius lang ang polar equation niya. Dito, nadadamay pa rin mula sa center, dun sa origin. So sa center ng ating circle. So ang R natin ay magsisimula pa rin sa 0. So we have R interval from 0 to 2. For the theta interval, dito may theta equals 0 tayo. Pero ano kaya yung theta na nagko-correspond sa y equals x? Okay? So hanapin natin yon. So y equals x, si y ay r sine theta, si x ay r cosine theta. So if you take y divided by x, you get r sine theta over r cosine theta. Cancelled yung r. So we get sine theta and over cosine theta. So that is tangent theta. So ibig sabihin nun, itong y, square root of 2, divided by itong x, square root of 2, ay equal lang sa tangent theta, where theta is in quadrant 1. Okay? Simplifying, we have tangent theta equals 1, so theta is equal to pi over 4. Hence, this is theta equals pi over 4. So our theta interval is from 0 to pi over 4. Okay? Now, for the integrand, may x squared plus y squared din naman dyan. Palitan natin ng r squared. Then yung dA, palitan natin ng r d theta. Okay na. We can now convert our double integral into polar form. So we have the double integral of 1 plus r squared multiplied by r d theta. So ito yung 1 over 1 plus x squared plus y squared. Ito naman si dA. And then ang ating r limits of integration ay 0 to 2, and then theta limits of integration ay 0 to pi over 4. Okay? Again, kayo nang bahala kung paano makuha yung antiderivative na to, yung complete solution. Pero, dahil ko dito kung ano yung pwede natin magamit, we can just let u equals 1 plus as r squared. Okay? So this is doable by u substitution with u equals 1 plus r squared. If you do that, ang mangyayari lang may 1 over u ka times some scalar. So, ina-expect natin talaga na yung ating antiderivative with respect to r ay in terms of ln function. In particular, we will get the following. So, ln of the quantity 1 plus r squared, yung naka-absolute value. Pero pwede mo nang alisin yan since 1 plus r squared is positive already. And then divided by 2, evaluated from 0 to 2. So, sa 2, we have 1 plus 2 squared, we have 1 plus 4, so 5. Yun ay ln 5 over 2. And then sa 0, we have ln 1 divided by 2. ln 1 is 0, so we cancel this term. And so we have the integral of ln 5 over 2 with respect to theta from 0 to pi over 4. So constant lang to, kaya i-attach lang natin dyan si theta. So we have the following, and then evaluated from 0 to pi over 4. So sa pi over 4, we get pi ln 5 divided by 8, and then sa 0, we get 0. So our final answer is pi ln 5 divided by 8. Okay? So that's it for the first set of exercises on double integrals in polar coordinates. It's sa part 2. See you!